Hi students, welcome to Techie Well1. Myself D. Vinod, working as assistant professor in the Department of Electronics and Communication Engineering at Sri Shanmuga College of Engineering and Technology. Today we are going to see the topic of computer fundamentals. So in this video we are covering some few topics about the computer fundamentals. First one is the basic functional units of computer. Second one, functional units, basic operational concepts, but such as third one, software performance. Fourth one, one human architecture. Up, fifth one, operation and operations of computer. Sixth one, hardware description. Next, instance set architecture. We call it as a short form is as ISA, and then addressing modes. So these are the topics we are covered in this video. After the end of this lecture, the students can be able to understand what is meant by computer fundamentals. So what is in a computer? A computer is a system that performs operations on data. To do this, it consists of five main functional units that work in concrete. So actually, the computer fundamentals, we have here five different blocks or different functional units to operate our system. So first one is here input unit, second one memory unit, third one ALU, we call it as arithmetic logic unit, and control unit, last one output unit. So this five functional unit covers here whole system. We call it as a computer fundamentals to operation or to perform on data. For an example, we call it as addition or suppression. We are get the two data. After this, we get your two data, and then if we do addition or suppression by giving our data. So this is a normal or general black diagram of computer fundamentals. So the first one is a input device. Second one is a CPU. Third one is output device. Fourth one memory unit. The CPU consists of control unit and then logical unit. So input we are using a keyboard or mouse. The output is a peripheral device. Is a, for example, is be an printer or printers are any screens and storage memory and central processing unit CPU. So CPU is here. Nothing is a combination of control unit and then logical unit. Okay, and then operating system OS. So now input unit. This is how data and the instructions enter the computer. For example, include a keyboard, mouse, scanner, or touch screen. These are the some of the examples how we are giving data or insert to perform some specific or particular task for our computer by using keyboard, mouse, scanner, and touch screen, and then storage unit. So this is a main where we are entering, we are giving the input, no, we are giving the input some instruction. The instruction should be stored in a memory unit. This memory unit is be classified into two memory. First one is called it as a primary memory. Second one is called it as secondary memory. Primary memory and then secondary memory. In a primary memory, we call it as a volatile memory. I will explain later what is meant by volatile memory. Volatile memory is to store data and instruction currently being processed by the CPU. CPU is central processing unit. This central processing unit stores the data and instruction currently being processed by the CPU. And the secondary memory, HDD, SSD, or some of the example for storage of secondary memory is the long-term storage of program and data. So compared to primary memory, secondary memory is nothing. It stores data and instruction currently being processed by the CPU. This is a primary memory. And in secondary memory, we are using long-term storage of programs and data. Anytime or any time we are get the data from is only in secondary data only. And now, so what is the difference between volatile memory and then non-volatile memory? First one is data erosion, losses of data when power is switched off, but in retains data even without power. So once the power is switched off, power is off, we lost our data. But in non-volatile memory, once the power is switched off also, the data will not losses. Second one, primary uses. So compared to volatile and non-volatile, volatile memory has a temporary storage of active data and programs. But in non-volatile memory, long-term storage of files, programs, and operating systems. And then third feature is speed. Compared to volatile non-volatile, volatile have faster, but in non-volatile slower than SSD or faster than HTC. Examples of volatile memory is RAM and cache memory. A non-volatile memory SSD, HDD, flash drives. So cost-wise is expensive. A non-volatile less expensive. CPU access can be accessed directly quickly by the CPU. Data must be copied to volatile memory for the CPU to process. So these are the some of the features of volatile and non-volatile memory. So again, we call it we have to revision that volatile memory once the power is switched off the data should be erased, but in non-volatile memory once the power is switched off the data should not be losses, we easily get back. This is a continued process. And then primary uses we are using temporary storage for active data and programs, but non-volatile memory, we are using files program and OIT. So some important files are it should be stored in non-volatile memory. So we are here. I mentioned this the SSDs and HDS. What is SSD and HDD? So hard disk drives is called it as HDD, and SSD is called it as solid state drives. Okay, say this is some comparison between SSD and HDD. So SSD is already I would discuss. No, I informed what is the operation of SSD is a solid state drives and hard disk drives. So SSD is faster compared to HDD. HDD far slower than faster SSD. So SSD have short lifespan, but in HDD longer lifespan. SSD more expensive, HDD is a cheaper. And here SSD there is no any non-mechanical parts, only flash type only we are available in SSD, but in HDD we have here some moving parts to mechanical as like a mechanical moving parts. So stock recent and fragile. Best for storage in operating system gaming. This SSD is mainly supporting for gaming apps and frequency user files. Best for storage of extra data as like movies, photos, and documents. Large files of data we are using by an HDD. So in my point of view, which one is best means I am referred to HDD. Okay, or no, what is meant by arithmetic logical unit? This is the computational brain of the computer. This is a brain of the computer. It performs either addition, subtraction, and some logical operations as like comparison or and operation or operation, not operation. So whatever the instruction we are storing in memory, based on this memory, so some of the arithmetical logical instructions are feed from in the memory unit. It should be fetched from memory unit, and it should be do some arithmetical and logical unit operations. And second one, next one is a control unit. So control unit is a central nerve of the system. It guides the operation of all units. It fetches instruction from memory and then decodes and coordinate the ALU registers and memory to execute them. So this is a we call it as a control unit. It's a central nerve of the CPU. Okay, and finally output unit. This is how the computer presents the results of processing to the outside world. Example include monitors and printers and speakers. These are the some of the output unit. So we have seen the basic functional blocks of CPU. So CPU this is this black diagram represents computer fundamentals. So here we have a input and then output and then memory. Whole system we call it as a CPU. CPU is a combination of control unit and then logical unit. So we are seeing the what is meant by input unit, what is meant by memory unit, and then difference between volatile and non-volatile memory, and then what is the difference between SSD and HDD, and what is the definition of ALU, and what is the definition of CU. C is control unit and then output unit. These are the basic operational concept. No, no, basic operational concept. The fundamental operation of a computer is to execute a program. Executing program is we have loaded a some addition of two datas. First one, we give first input. This input is stored in a memory or register. After that, again I get another data from input device, and this one also stored in either memory or register. We get here two data. After that, we are giving one more instruction. So to I am getting the two data. it should be either addition or suppression or doing any logical operation. It should be we are written in insertion, third insertion. After the insertion, the arithmetical logical unit performs the operations and it will give the some outputs. Okay, so this output is should be stored in a some type registers or either output screen. So this is a basic one more example for to understand basic operational concepts. So this one I am saying the fundamental operation of computer is to execute a program which is a sequence of instructions stored in a memory. So already I told no what is in the fetch. The control unit returns the next instruction from the memory address stored in the program counter. So what is mean by program counter is nothing but is a plus one. If an exam plus one, if I get the first insertion, get the first insertion, the foreground counter plus one. So what is my plus one? It should be moved to next insertion. Then what is the next insertion? We want to get the another data from the input device. So this is a step by step. The insertion will be moved by using this program register program counter. In case in our system the program counter is not properly working, our whole system should be collapsed. Okay, so what is in the fetch again? The control unit returns the next instruction from the memory address stored in the program counter and then decode. The control unit interrupts the insertion, determine what operation. Is in decode means, we are getting two data now. So this one is add operation or load operation need to perform need to be performed and identifying the operand the data to be operated on. Okay, so first one we get the data from register and uh, what type of decode we want to what type of operation we want to do. Third one execute, so we know what type of operation we want to do. For example, addition. So addition means that we add in the two datas. We add in the two datas. So this one is done by the execute method. And finally, after we are getting the result, it should be stored in the register. So and again, the foreground counter is then updated to point of the next insertion to repeat. So this is a one human architecture. So this diagram shows the this one B diagram shows the one human architecture and A diagram represents Harvard architecture. In an Harvard architecture, we have separate memory for data, separate memory for insertion. But in one human architecture, single memory itself we can store our data and insertion memory. Okay, you can understand the difference between one human or Harvard architecture. So this diagram shows the Harvard architecture. Here we have a separate memory for data, separate memory for insertion memory, and here this one is represented as a one human architecture. We have a single memory. It should be have a data and insertion memory in a single memory itself. So this is a one human architecture. Actually, it was built by in by John von Neumann in 1945. Okay, here already I just explained where both instruction and data are stored in the same memory. This allows a computer to execute programs that are loaded from memory and to modify or switch to different programs simply by changing the content of that memory by self-storage concept. Okay, so what do you mean by storage program concept? Both instructions and data are stored in the same main memory. This is important because it allows the computer to be easily reprogrammed for different tasks by simply loaded a new program into memory. So by this one is we are referring one human architecture because in a single memory itself we can write insertion and data in a single memory itself. So we are doing a different task is easily to write new program into a memory structure. Okay, and the sequential instruction processing. Here, instructions are executed one after another. One after another, this process is done by using a program counter. In this order, we are executing our codings. The order fetch from memory. There is no any collapse. Okay, and then common bus structure. Here, a single shared pathway is used to So single way pathway means, okay, this is a single way pathway. In this pathway, we are transmitting data insertion in a single pathway. But in Harvard, data memory have a single one bus, one path. Insertion memory have a one bus. It means one path. That is a two different path transmit our data to the CPU or memory. Here, single path memory we are using to execute. Okay.